Hello students, so today we will study about CapillaryTube. Before this video, one video we have done on surface tension, in which I explained you that how surface tension works, some of the examples we have took, right? So today we are studying about CapillaryTube. Before that, let's go understand what is angle of contact, okay? In the CapillaryTube, what is angle of contact, okay? So what we are saying is, angle of contact is the angle enclosed between the tangent plane at the liquid surface and tangent plane at the solid surface at the point of contact inside the liquid. Okay. What we are saying is, let me explain. This is a liquid surface, okay, this blue color, okay. I mentioned already because it will be taking too much time. So everything is mentioned already, okay. Understand one by one, then I will explain it, okay. What we are saying is, angle between this is liquid surface, right? This is liquid surface. Here I want to calculate angle of contact. This is liquid surface. So liquid surface, you draw a tangent, okay. This is solid surface, white line, okay, right? This is another surface, so you draw a tangent. So straight is this is straight surface, right? The tangent will come on this line only, right? So this is one tangent, this green line is one tangent. Between them there is an angle that is known as theta c, angle of contact. Understood? Here the surface is like this, the liquid surface is this way, the straight surface, so tangent is here, this is straight here, so angle is 90, right? Here this is the liquid surface, so tangent on the liquid surface this way. This is solid surface, straight line, so tangent will be on the solid surface only, right? Straight line, tangent, same line only, right? So this will be your angle of contact. Understood? Okay, this is what angle of contact is. So why it is happening that this is a dip and this is 90 degree, this is more than 90? Why it is happening? First understand that there are two kind of forces, one is cohesive forces and one is adhesive forces, okay. What is that? Cohesive forces and adhesive forces, okay. What is cohesive forces? Understand by this, okay. Basically, when we have studied the surface tension, that time I told you that on the drop, on not the drop, sorry, on one particle, okay, there will be forces, attracting forces from each side, right? From all the side there will be attractive force, right? Equal amount attractive force, this will be particle here only, right? There is a momentum in the liquid particles, but there will be equal amount of forces from all the sides, right? But in this case, when the liquid surface is like this, right, and the particle which is here nearby this solid surface, for that particle we are studying, okay. For that particle what you say is, these three side forces are not there. If you consider like this particle, every side there is a force, right? But if this side, that particle is on the corner, right, for that these three sides no force is there, right? There is only this 1/4 only we have the forces, right? So I can say the net cohesive force in this case will come like this at the FC, okay, and we say this is at a 45 exactly, okay, like this we say. Understood what we said? Total all side there was a cohesive force, right, between the particle and like let's say take the example of water. So between water cohesive force, right? So that between water and this side water, right, 1/4, so there is cohesive forces, so net cohesive force came this side, right? Understood? Now what happens is, this is cohesive force, so cohesive force was this side, one component this side, FC by √2 cos 45, right? In this side same 45 angle, so this is also cos 45 FC by √2, both side FC by √2, FC by √2, okay. And then comes this FA. FA is what? Adhesive force. Adhesive forces are what? Between the surface particles, which are different, maybe some iron or something, right? Glass, maybe glass, iron, whatever. So these glass particles and the water particle, they coming in contact, right? So this will have a adhesive force, okay. So these particles are on the these particles are like this, continuously on the what we say wall, right? Okay, so here is your particle, here is your water particle, here is your water particle, so it will have attracted like this, okay, to certain range. So net force will come this direction, right? So that's why I mentioned FA this direction, okay. Understood? Got it? So there is an FA, FC by √2, FC by √2. Similarly here FC by √2, FC by √2, FC by √2, FC by √2 and FA. Okay, this much clear. Now comes second thing. one thing, if you remember from the fluid mechanics, what we say is that your net force on the surface, when the particle, okay, on the surface there is a particle. If the net force on that particle is F net in a particular direction, okay, then that surface of the liquid will be perpendicular to this. Surface will be like this. Okay, what we say, if F net is coming this side, then surface will be like this. Okay, they will be perpendicular to each other. That is already studied, right? So by that, if we call it here, if we take this case, right? So here, which force is dominant? That is deciding what will be the angle of contact. See how. What we are saying in this case is that we say that Fc by root 2, okay, is less than Fa. So Fa is dominant force. So net force in x direction, if you see, is this direction, right? Because Fa is dominant, right? Fa is dominant, so this side. So one component is this side, Fc by root 2 this side. So net force came this side. Okay. If net force is on the particle is this side, then surface will be like this. Got it? Surface will be like this, and this is all happening. So angle of contact came acute angle. That's why angle of contact is coming below 90, 0 to 90. Why? Because net force is this direction. Here Fa, adhesive forces are dominant than the cohesive force by root 2 component. Okay, that's how. Here what is happening? If this component balance, some cases balance also possible. Okay, so if this balance, then we will say angle of contact is 90 degree. Okay, when this condition follows. Got it? If your Fc by root 2 component is higher, right, then your Fc by root 2 is higher than Fa. Then what will happen? This component, this side x, your x direction force is what? Positive x direction. And this side, one component is this side, one component positive x direction. So net force will come in this direction. If F net came this direction, then surface will be perpendicular to that. So surface will go like this. Understood? That's how surface is coming. So angle of contact is coming obtuse. Understood? 90 to 180. Okay. That's how angle of contact is working. Got it? Understood? Now see, come to the capillary tube. Okay. Now what will happen is, if your angle of contact is acute, means the surface is bending like this downward, right? Here we see this way. Okay. If it is happening like this, then water will rise in the capillary. Okay. And if this is 90 degree, then it will not rise. If it is obtuse, then it will dip. Okay. There will be a depress. Understood? That's what he is saying here. Why it is happening, that we will see next. Okay. Now see, what we are saying here is, we took this capillary tube. What is, first of all, capillary tube? Also you can see a glass tube with fine bore. Fine bore means fine edge is here, the final edge, smooth boundary, and open at both ends is called capillary tube. Okay, simple capillary tube is there. You can search for another video. You can see how the capillary tube looks. You can see the Google search you can do. Okay, so that is capillary tube. Open from both ends. You dip in the water. So it is very, like you can say, very small radius. Okay, so that's why you can see a very high amount of water rising there. Normally, if you take, then you will not able to see that much rise, and you will see, sir, where is this phenomena working? This works. Okay. If your radius is very small, then you will able to observe it very high. Okay. That also you can search on the Google. See, next, now how it happens, why it happens, that let's understand that thing. Okay. So we are taking is here one, what we say, capillary tube. Okay. What we are saying is, you dip the capillary tube little bit, water is there, capillary tube radius is small r. Okay. Assuming that angle of contact is between 0 to 90, so water will rise. Why it will rise, I will explain. Hold on. So what we have, density of the liquid we have rho, angle of contact theta c, surface tension is capital T, and small r is radius of the tube. Okay, that's what. And capital R is radius of the curvature. Okay, radius of curvature means this. Okay, you have studied in the radius of curvature, the pressure. Now let's see that thing also. See how it works. See, here when you will say this side pressure is how much, outside pressure, atmospheric, P naught, right? So here P naught pressure, outside P naught. Here also just above this surface, what is the pressure? P naught. Okay. This from the concave side, you are going convex side, right? In the liquid. So what will happen? Pressure will decrease. So inside pressure is what? P naught minus 2T by R, right? P naught minus 2T by R. Now understand why it is rising. If you say that it didn't rise, sir, I will take that it will not rise. So let's take it will not rise. So it is at the same level, but the angle will change, right? Angle of contact, how it will change, that I already explained, right? So angle of contact changed. And this is the surface, how? And this is the outside liquid, right? Okay. Now this is the outside liquid A point. A point is here and this is the B point. Now B point came here only, right? So what you are saying here, pressure P naught. Here A point pressure P naught. Okay. And then as you are going liquid inside the liquid, right? You are saying P naught minus 2T by R. Okay. P naught minus 2T by R, right? Pressure will drop. Okay. And then inside the liquid at the same horizontal level. This is approximately same horizontal level, right? So we can say this will be at same horizontal because this is not that much high. You will see. Okay. So we can say that you are saying that P naught in the same liquid, same horizontal level, pressure is same, right? So P naught is equals to P naught minus 2T by R. So you are saying 2T by R is 0. That is not true, right? Okay. For that to happen, now because of that reason, to balance this factor, this water will rise. Now see, this will be balanced. See how? Here I am saying P naught. Okay. As you went inside, what is the pressure? P naught minus 2T by R. Then there is an H height rise. So what when you will go down in the liquid, what will happen? Increase by rho gs. So we are saying P naught minus 2T by R came inside the liquid. Now going H height down. So plus rho gh. This is your PB, right? At pressure at this point, right? Same horizontal level, A point, that is the pressure is P naught from this side, right? Atmospheric pressure P naught. Now from here, if you solve, you will get a H. Understood? That's why water is rising. To compensate this factor, minus 2T by R is happening, right? There is a minus 2T by R. Then there will be a plus rho gh that will balance. And then P naught is equals to P naught will come. Okay? Understood? So that's how this is coming. So this is H 2T by rho g R. Capital R is radius of curvature. When you write down here 2T by R, that time R is your radius of curvature. So from surface tension we remember, right? 2T by R only because one surface change, right? From air to liquid. Understood? Okay, this factor I told already in the surface tension. One lecture is there on the YouTube. It is uploaded. You can see that also. Okay. Now let's come for the next thing. Here, generally what happens, ma'am, in the question you will not have the radius of curvature. You will have the radius of the tube, right? So let's find out what is the relation between radius of the tube and radius of curvature. So see here, what we are saying is, understand this diagram. This is angle of contact theta c. Okay. This is how radius of curvature. This will be part of the circle, right? So this is capital R, radius of curvature. This is small r, radius of the tube, right? So from this triangle, I can say this is small r and this is capital R, right? So from here cos theta, if you write down r cos theta c is equals to small r, because this is theta c, this is theta c. So this is 90 minus theta c, so this is theta c. Okay, that's how. So that's how came r cos theta c is equals to small r, and capital R is equals to small r upon cos theta c. So in that formula, in this formula, if you put the value of capital R, because capital R is generally not given, okay, small r is given. So you have to check in the question also. Derivation is very easy, nothing much. So you can derive and you can see what is given or what is not given, right? So H is equals to 2T by rho gr into cos theta c. Okay, this is the main formula you have to remember. If you want to, otherwise very easy to derive and all, you can, but many questions, many easy questions come, so you can remember it. Okay, understood? I think nothing is left here, everything is covered. Okay, how? When you will have a dip, that time. Now if someone asks like, how sir, if in convex why it is going down, that also you understand. Here only I will explain. Understand? If you have a capillary like this, okay, and surface is becoming like this, okay, what will happen? This side P naught, okay, if you are going inside, what will happen? Increase in the pressure. What will happen? Increase in the pressure. So this side pressure is P naught plus 2T by R. P naught plus 2T by R, right? But liquid surface is at the same horizontal level, then it will be not able to balance, right? So what will happen? Liquid will go this side, okay. Then what will happen? Here pressure P naught, it will go rho g h, h down. Understood? So this side pressure is how much? P naught plus rho g h. So here the increment plus 2T by R is balanced by rho g h. That's why it goes down. to balance the pressure, okay, because in the same liquid at the same horizontal level where pressure will be same, right? That's why it is going down. So to balance this factor, now P naught plus rho gh is P naught is equals to P naught plus 2T by R. Same H will come, okay, H will come the same formula will be coming. That's why we are solving for the concave only, sorry, for the concave part. How you are seeing it, it depends. From seeing from this side it is convex, from seeing from this side it is concave, right? Just there is an acute angle, right? So in acute angle we are solving, obtuse also same thing will come, okay. So if you put theta c as 90 degree, this will come 0, right? So okay, now let's go next thing. So here we are discussing method 2. I will tell you now only why we are discussing method 2, because there are questions which can be solved by method 2 only. You will find in SC Verma, okay, in SC Verma you will find out question number 27, I think 27 or 28, okay. That is same, by solving by method 2 only you will get it, okay. How? This is capillary rise, okay, rise happened. Now you take this liquid only. What I am taking here, what is this diagram? I am taking this liquid only, this here, this liquid which rised, right? Why it is rising? Because of surface tension, right? Because of surface tension, this cohesive, adhesive, this is all things are happening, right? So we will solve with the surface tension now. See, surface tension will come this side, right? Now it is a circle, like this circle is there, right? Capillary, understood? So what is the surface in touch? 2 pi r, right? So surface 2 pi r into T, this is the force, okay, and we are taking vertical component this side, so this will be T into 2 pi r, this is force into cos theta c, okay, this is theta c, so this will be also theta c, so T the F cos theta c, okay, understood? This is the force, got it? So this side component is T into 2 pi r into cos theta c. This is only, this force is rising this, balancing this mg. So mg is what? Balancing this mass of this block, which is rise water, right? So mg, mass, what you will write down? Density into volume. Write this, density into volume. Density into volume is what? Pi r square. R is what? Radius of the tube. Pi r square into h. This is your volume. Okay. So density into volume, mass into gravity. Okay. That's how this came formula. Same formula, right? I will explain you a little bit about that question in SC Verma. What happens in SC Verma? There is an two slab putting parallel, okay, and there is a rise in the water, right? So here how you will solve? Here when you will calculate this surface tension T into, you can read that question, okay, T into 2 pi r, you will say this surface, what is the surface in touch? Okay, you will say 2L. Okay, this will come two slabs like this parallel putting. So water is rising like this. So T into 2L, and then you take a component of the force cos theta c is equals to mg. Mass you can write down, density into volume. Okay, from there h will come. Okay, so that's why method 2 is also important. See, in the JEE perspective, if you see, you should know every kind of method to solve the question, because we don't know, there will be questions which can be solved from a particular method only, right? So we should be clear with everything. Okay, revise the notes again and again and you will get it. Okay, next thing, see, this is Zurin's law. This is nothing, just the formula only. See, h is inversely proportional to r, right? That only is saying h is inversely proportional to r. Okay, so he gave his name. Okay, now see, one note is there. Okay, this maybe you have seen, if you put a glass, okay, and you pour water, what happens in a glass and water contact angle is acute angle. Okay, if you take a pure water, that is 0 angle. Okay, you will not able to observe that. So there is an acute angle. Okay, but if you pour water, continuously pouring, then you will see if it is above the level of the glass. Okay, take a normal glass. Okay, the glass only. Okay, the transparent glass. So when you will take, what will happen? There will be an angle increase. Okay, water will come above the level of glass, but still it is inside only, right? It is not spilling out. Okay, so for that how it happens, you know this relation, right? You know this relation, but sometime what will happen, your capillary tube will be not of enough height, right? Not of enough height. So what will happen, this pressure have to be balanced, right? Pressure have to be balanced. So what will happen is, this cos theta c, this theta, so from this relation you can see, as theta c increases, h will decrease, right? This everyone understand how the cos works, right? So as theta c increases, h will decrease. So what will happen if your height is not enough? Then what this contact angle will change. It will change himself, okay, and it will make him such a way at certain angle it will stop, so that this equation is balanced. Understood? Still, if it is not more than enough, then it will spill out. Okay, that is another reason. Okay, but it will try to balance this thing. Okay, it will try to maintain. So it will, if height is not enough, then it will change the contact angle. That kind of question are also asked, that if he will give 2 centimeter is the capillary tube. Okay, we have a 2 centimeter capillary tube or 5 centimeter capillary tube. Is this enough or not? Like that he will ask. So you calculate the enough one, and then you will answer the question that it is enough or not. Okay, what is the minimum height of capillary tube required, okay, for this particular experiment, that you have to answer. Okay, now see some questions we have. First question he is asking, if all the glass capillary tube have same radius, then in which capillary water will rise to more height? Can you answer? If you see by the formula, H is equals to 2t cos theta c by rho g r, right? Understand? He is saying if all the glass capillary tubes have same radius, so same tubes, right? So surface tension same. Okay, theta c, he is saying same glass, same water, so theta c is also same. Density is same, g is same, and r also he mentioned same, right? So h will be same, because how we balance? We balance with rho g r. Okay, rho g h. Understand the pressure which we balanced? How we did? P naught minus 2t by r plus rho gh. So rho gh will go straight. So he is asking height. He is not asking about the length. That is another question. So height, rho gh you go, right? So rho gh will be same. But it doesn't matter how much length you are going. When you are saying here in this capillary, if you talk about the length, I can assume a small capillary here like this. Keep this big, okay, and I can assume like this. So you will take this shape also. No, or you straight height in which gravity is acting, that way only. That's it. Got the point? So here height will be same. So I can say h is same for all. Understood? Height will be same for all. Next question, see. Initially height of liquid rises in the tube is capital H. Okay, so this is small h. This is small h. Okay. Now if tube makes angle theta with the vertical, then find the length of water column in tube. So he is saying like this, that if now tube is at certain angle in the liquid, so till how much height liquid will rise. Fine. Like this it is. Making angle theta with the vertical. Okay. So how much is this length he is asking? How much L? Okay. So I can say L sin theta, right? L cos theta, sorry. L cos theta is equals to H. Height will be same, as I told in the previous question, right? Height will be the same. In this and in this, height is same, right? That only is discussing. In this, if this is H height, then this is also H height, right? So he is asking this L. Got it? The questions are same only. Okay. So what we can say, L cos theta is equals to H. So he is asking L. He is asking L. So L is equals to H by cos theta. Understood? Cos theta C you can say. Okay. That's your answer. Sorry, cos theta only. Theta. Okay. Not theta C. Okay. Understood? I hope this is clear. So this is about the capillary tube. Okay. Understood? Thank you.